Welcome to my presentation. In this presentation, let us look at some more examples related to proportions. Let's take an example here, and in this example, we want to find the value of x. We want to solve for x, and the problem is as follows. 3 over x plus 2 is equal to 8 over 7. So to find the value of x, we will break it down into these different steps. Step number 1, we will use the proportions rule, and the proportions rule is telling us that if we have two ratios, a over b, and if that is equal to another ratio, c over d, we can cross multiply these and then write this proportions rule as follows. We can write it out as a times d is equal to b times c. We will use this rule to the given problem to be able to solve for this unknown quantity x. So what we have here is 3 over x plus 2 is equal to 8 over 7. We're going to cross multiply, and when we cross multiply, we're going to arrive at these. We're going to arrive at this following terms. 3 times 7 is equal to 8 times x plus 2. We want to solve for x. In this case, we're going to simplify these terms, and let's write that as step number 2. In step number 2, we're going to simplify what we have in this part of this step number 1. 3 times 7 is 21. We'll simplify that, and then now we want to distribute the 8 which is outside of the parenthesis to every one of the terms inside the parenthesis. 8 times 2, 8 times x is 8x, and then 8 times 2 is 16. And now we're going to use our addition, subtraction, multiplication, division properties to be able to isolate the x term and solve for x, and solve for the x term. So in step number 3, we will use the subtraction property. We'll try to get rid of the 16 which is associated with 8x. So we're going to subtract, let me write it with this ink here, negative 16, negative 16. We are subtracting 16 on both sides of the equation. When we do that, the positive 16, negative 16 cancels out, leaving us with 8x on the right hand side is equal to 21 minus 16. 21 minus 16 is equal to 5. So in our next step, step number 4, we need to still find the value of x. We have 8x equals to 5. We want the value of 1x. So what do? We are going to divide 8x by the number 8, because that is how we want to get rid of the 8 there, and then we'll do the same thing on the right hand side as well. 5 over 8. We are dividing by 8 on both sides of the equation. When we do that, the 8 in the numerator, 8 in the denominator cancels out, and then that is going to give us a value as x equals to 5 over 8, and that is our answer. That is where we want to leave it. So by using the proportions rule, we were able to solve for x using the proportions rule, and also using the addition, subtraction, multiplication, and division properties to find the value of x. Let's look at another example. In this example, let us say we want to find the unknown quantity. We want to solve for, let me write this, solve this equation. A minus 7 divided by 8 is equal to 3 over 5. The variable here is a, and we want to go find the value of a. So let's write these different steps in here. Step number 1, we're going to use the proportions property, and if we have, and the proportions rule property is telling us that if we have two fractions, a over b, and if we have another fraction, c over d, and if we were to equate those two fractions, we can write the proportions rule as follows. A times D is equal to B times C. And by equating these means and extremes means and extreme terms, we should be able to find the unknown quantity. In our problem, what we have here is a minus 7 divided by 8 is equal to 3 over 5. We're going to cross multiply these, and then we want to find the value of a. And when we do that, this is the way it is going to come out. This is the way it's going to come out. 5 times a minus 7 is equal to 8 times 3. And in here we want, let's write this as this next step number 2. 5 needs to be distributed to every one of the terms inside this set of parentheses, a minus 7. 5 times a is 5a, and then 5 times 7 is 35, is equal to 8 times 3 is 24. And we want to simplify this some more. And the way to simplify this is, we want to isolate the a term, and therefore we want to step by step get rid of the terms which are associated with a. We have negative 35 in here, therefore we're going to, if we want to get rid of the 35, we're going to add 35, a number which is equal to but opposite in sign of negative 35. And when we do that, we're going to introduce it on both sides of the equation like that. And when we do that, the positive 35 and negative 35 cancels out on the left hand side, leaving us with 5a is equal to positive 24 minus 35, and that value is going to be equal to negative 9. No, in fact, this value should be a positive 35. We are introducing positive 35 on both sides of the equation. I'm sorry about that. So let us correct that silly mistake which I did. And therefore, this value is going to be 24 plus 35 is going to be equal to 59, positive 59. And we need to find the value of a. And we'll write that in this next step, step number 3. Is to find the value of a, or to find the value of 1a, we're going to take 5a divided by 5 is equal to 59 divided by 5. And since when we have the similar numbers in the numerator and in the denominator, we can cancel them out. Therefore, the value of a is going to be equal to 59 over 5. In terms of, this is an improper fraction, we know that. When the numerator is larger than the denominator, we call those types of fractions as improper fractions. We can also express it as a decimal number, or as a fraction, or as a mixed number. How do we do that? We take 59 and then divide it by 5. 5 times 1 is 5. When we subtract, this cancels out and we need to borrow the 9. 5 times 1 is 5. We repeat the process again. When we subtract, we are left with 4. So we can write 59 over 4 as 11 4 over 5. That's another way of writing it in terms of mixed number. We can either express this answer as an improper fraction or write it out as a mixed number in this manner, or we can also write it in terms of a decimal number. If we take this a little bit further, and if I were to say there is a decimal point after 59, and we can add as many zeros as possible after that, it is not going to count. But if we want to write the answer in terms of a decimal number, we can borrow the 0 down here, and then we can we want to put a decimal point after the 11 there, and then now we're going to recall our 5 times table and say 5 times what number is equal to or less than 40. 5 times 8 is equal to 40, and therefore there is no more remainder when we subtract, and therefore we can express 11 4 over 5 in decimal format as 11.8. All of these are different ways of expressing the answer. Improper fraction 59 over 5, mixed number 11.4 over 5, and then decimal format 11.8. So this is the way we want to be able to solve for the unknown quantity using the proportions rule, and also applying the addition, subtraction, multiplication, or division, whichever is applicable in this case, and then be able to find the value of the unknown quantity. In this case, the variable is a, and we were able to find the value of that. In my next presentation, we shall look at some more examples related to proportions.